Hello everybody, I am Engineer Tryphon Mabanza. I have a honors degree in clinical technology and master degree in materials engineering of the University of Limerick. So today I'm going to talk about the development of lignin and polybutylene succinate formulation for packaging application. So I'm just going to show you how I mixed two different polymers materials to make packages, and to also that is the same material can be used to manufacture many different articles for automobiles like cars, aircraft. The same materials can also be used to manufacture medical devices, many articles. So the objective of this video is to demonstrate the step-by-step procedures in developing lignin polybutylene succinate. So how I proceed to develop the materials that can be used to manufacture different articles such as plastic bags, bottles, medical devices components, car parts, aircraft parts. And also I will show the after manufacturing that materials, which techniques to use to test that materials, if they are strong, if they meet the criteria to be used as material intended for the manufacturing of packages or car parts, aircraft parts like. And is the video one or the part one of the video, because in the second parts I will show now how I will manufacture the product based on the materials I developed. I mean, I will show how to make packages with the materials I mixed. And the methodology is to show how I mixed the two raw materials, lignin and PBS, using some equipment or some instrument like twin screws compounder or twin screw extrusion machine. Twin screw means that that machine I used have two type of screws, and the technique to test if the material I produced is suitable for making packages, making aircraft parts, car parts, pharmaceutical products parts, like those different tests are DSC, which stands for differential scanning calorimetry, and DMA, which stands for dynamic mechanical analysis, and RHEOLOGY instruments. All the three are the different tests I performed on the material I produced to show if a force is applied to that material, how that material can behave. The material will be broken, or the material will resist to a certain force. Like, so before to show how I produced the material to use to manufacture packages or automotive parts, it's very important to explain each part I used, because as I said at the beginning, I have mixed two different components or two different polymers such as lignin and polybutylene succinate. So in this slide, I'm going to talk first about lignin. Lignin is a product that can be obtained from the plant. That's why the first line said that lignin comes from a Latin word meaning wood. So it is a plant polymer. Polymer is just a material that has many different parts. And tricarboxylic acid, TCA, is one of the main part of the lignin. And an example of tricarboxylic acid is a citric acid. And tricarboxylic acid means that there is 3 different types of carboxylic acid in lignin. And the chemical structure of lignin is a C6H5 and OH. OH is just the signification of all acids. When you see OH at the end of any chemical structure, it means that component is an acid. And lignin is insoluble in water and alcohol. It means that when lignin is inserted into a water, so it will not mix with the water. Lignin will stand up of the water. And lignin is soluble in weak alkaline solution. Here it means that when lignin is mixed with any alkaline solution, now lignin will mix. So an example of alkaline solution will be like bicarbonate. And lignin decomposes very slowly and increases soil moisture retention. It means that when lignin is on the land or on the soil, and you spill the water on that soil, the soil will not absorb the water because of the lignin over it. But lignin decomposes very slowly, it breaks down very slowly. And the application of lignin, so you can see a lignin is here in the brown color, and here is the chemical structure of lignin. Is a very complex polymer component. So this material can be used to manufacture automotive parts like car parts, helicopter parts, aircraft parts, tractor parts. It can also be used to manufacture like some construction equipment, and to manufacture also pharmaceuticals, and to manufacture insulation material. Insulation materials means any materials that cannot enable the flow of the electricity. And lignin can also be used to manufacture coatings products, any product that can be used to cover anything, like to cover pharmaceuticals products, to cover products like. And the same products here can be also used to manufacture plastics bag, plastic bottles, anything in plastics can contain this product known as lignin or tricarboxylic acid. And we can also use lignin to manufacture paper and papyrus. Papyrus is just an old type of paper. So this is the first component I used. And the second component I used is polybutylene succinate or PBS. Polybutylene succinate also comes from the wood or from the plants. So it is also a biodegradable polymer. It means that polybutylene succinate decomposes also when is on the soil or in the water. They break down and they decompose. Polybutylene succinate is widely found in almost plants and animal tissues, and the chemical formula of PBS is CH2 and CO2H2. The external structure of polybutylene succinate is white. So here you can see polybutylene succinate in white color. It's a kind of salt, but it's not a salt. It's in grain structure and in white color. And it's very excellent biodegradability in soil. It decomposes in soil. It doesn't remain stable in soil. It decomposes. And this component has the same mechanical and thermal property like polyethylene and polypropylene. So polyethylene and polypropylene, they are also two types of polymers. They are widely used in most of industry to manufacture different materials like plastic bag, like pipeline, like aircraft products, car products, helicopter products, pharmaceutical products, medical devices, like. And polybutylene succinate here in white color can be used in food and cosmetic packagings, in textile industries, in biomedical sector, in disposable products such as tableware. Disposable products mean that any product that can be used only once or one time, and then they will be disposable. For example, to use this to make plates, pots for table or for kitchen purposes. So in this picture we can see some materials or products made using the two components I have explained to you, lignin and polybutylene. So like plastic bag, we have plastic bottles here. And the advantages of using those two components are that they decompose when they are on the soil. So they don't stay stable. They break down and they decompose. When they decompose, they become soil. And when they become soil, they also become food for plants. And actually, everywhere in the world, people and most of the industry, even most of the states, they need to use biodegradable material that will break down and will decompose in order to avoid environment pollution. And they are not toxic as well. They do not produce poison. And those material, lignin and PBS, consume less energy when they are used to manufacture products. It means they do not consume high energy like when we use metals to manufacture like cars, to manufacture other products in metallic materials, because metallic, they are hard, they are solid, and they require high energy to be processed. Because metal can be used to manufacture airplane, to manufacture guns, to manufacture many things, and we have different type of metals. But here we are not talking about metals. I just a little bit evoke metal because metals use consume high energy to be processed. But the disadvantages of the lignin and PBS are that they can contain heavy metal during the composition, especially when people throw lignin and PBS in bin containers, and they will be mixed with other different material there, and they will produce heavy metal during their decomposition. And in that case, they can lead to ocean pollution or sea pollution. And to be decomposed, these two components require water. So the problem will be if there is no rain, it could develop into a major problem managing this waste at such time. They can also constitute a kind of chemical exposure. So task 1 is experimental development of lignin PBS blend polymer. So you can see this flow chart is explaining the schematic diagram describing the process I used and the machine I used to mix the two components that will be in the future used to manufacture plastic bag or other products. So the first thing I used in laboratory was to use a metallic spoon and beaker balance to weight my two components, lignin and polybutylene succinate, and I also used a twin screw compounder. You see, this is the machine I used to mix my two components, and the machine name is twin screw compounder. Just twin screw compounder because the machine has two screws in conical shape, and I use the balance to weight the two components. The first weight was of 50% lignin and 50% polybutylene succinate. The second weight was of 60% lignin and 40% polybutylene succinate. The last sample was of 70% lignin and 30% polybutylene succinate. It means that the first sample of 50% lignin and 50% polybutylene succinate contain 10 grams of lignin and 10 grams of polybutylene succinate. It means both components were of the same weight, but the second component contained 12 grams of lignin and 8 grams of polybutylene succinate, and the third and last samples was of 40 grams of lignin and 6 grams of polybutylene succinate. Then after weighing my three samples, I on the machine. The machine is a twin screw compounder using the start button. And then the next procedure was to heat the barrel, because the process I used was a heat process, or a heat or hot melting process. So it requires to heat first the barrel. So this is the in front part of the barrel, and this is the last chamber of the barrel. So the material will go into this chamber to be compressed and then to flow out of this machine as an homogeneous material, as a uniform material. So homogeneous means just uniform materials, to obtain just one materials. And then after heating the barrel by setting the temperature, the in front temperature in 3 different zones, and the rear temperature in 3 different zones. The 3 different zones are in relation to the 3 different parts of the screws. The screws are 2 screws. We have the feeding zone. This is the big zone from here to here, and the middle zone is a little bit lighter, and that zone is called compressed zone. And the last zone is very tiny and is called metering zone. So the material will go from here to the compressed zone, and then to the last zone called metering zone, and it's from where the material will flow out. And then when I set the speed, I hit the barrel, I started putting the two components, lignin and PBS, into the machine using a hopper. A hopper is a kind of a funnel like. So you see, this is the hopper, is where I was putting my two components, lignin and PBS. This is just a small hopper because it's a mini machine, a small machine to use in laboratory, but in the industry they have big machine to produce high quantity of materials. So when I insert my component here, I use this plunger to push forward the material to the barrel here, where the material will be heated and compressed. And then after compressing the material using the twin screw compounder, the material, the two materials were flowing out. You see, this is the final product I obtained. So this phase sample contains the sample of 50% lignin and 50% polybutylene succinate, and the second sample contains 60% lignin and 40% polybutylene succinate, and the third sample contains 70% lignin and 30% polybutylene succinate. So these are the final products I produced by mixing the two material I showed you in the previous slide, in brown color and in white color. And this, in the second part of my video, I will show you how I used these two materials to make plastic bag, to make also aircraft parts, cars, components, medical devices, pharmaceutical products, to make paper, to make dishes, to make plates like, or cups, to make glass. And this slide is about the first analysis I have done on the manufactured components, or the tests I have performed on the material I produced. This test is known as differential scanning calorimetry. In short, is DSC. So with this test, I wanted just to know if the plastic bag is heated, how it will behave. What will be the reaction of the plastic bag I produced when it is heated? Or how the cars, the aircraft, the medical devices parts I produced, when is heated or when is placed in a heated environment, how it will behave. So the test is known as differential scanning calorimetry. And this is the schematic diagram to explain how I have done the test to know the heat behavior of my materials. So I use the machine model of Pyris 6, and the procedure was to heat the machine from 0 degree to 160 degree. 0 degree is just room temperature to the final temperature. Then I cooled down the process, starting from the last temperature to the starting temperature, and then I reheated the machine from 0 degree to 160 degree, so using DSC machine Pyris 6. And then I used a software known as Thermoanalysis 2000 software to know the property or the behavior of my material I produced. So here you see, when I was heating this machine, the red dots represent the heat flow, and here is the empty pan, and here is the sample pan where I put it, a small sample of the material I produced, to heat it and to know how it will react under heat effect. And this is the result of my test. So the sample of 50% lignin and 50% polybutylene succinate is a good sample. We can know it by this endothermic peak. So this sample of 50% can melt at 122 degrees Celsius. And the second sample was of 60% lignin and 40% polybutylene. It's not bad. It's a good sample as well, because it has an endothermic peak as well, meaning that even that sample can melt. When it's heated, it can melt. And when it's melted, it means that that material can be reprocessed, can be used again, or can be reworked to manufacture a new material, another material. So it can be recycled. And the last sample of 70% lignin and 30% PBS. We can see that in this sample, we have a high amount of lignin and less amount of polybutylene succinate. That's why we have this kind of a graph. We don't have a nanothermic peak here. That means this sample is not good to use to manufacture plastic bag to be used to produce aircraft car parts in plastic form. So it's not a good component for commercialization. It's in amorphous polymer. So in amorphous polymer has only a glass temperature, glass transition of this component is 29.89 degrees Celsius. It means that this material, when it's heated, it can change a little bit. And then from here, it will remain stable. It will not melt. It will not become liquid. And this is the example of the all four materials I will need to use in another instrument known as an an injection molding machine to produce parts of my wishes to be commercialized or to be used. So this is just the discussion about what I said previously, that these two samples are very good to be used to make parts 50-50 and 60-40 because they contain an equilibrated amount of the both components, lignin and polybutylene succinate. But the third component or the third sample of 70% of lignin and 30% of polybutylene succinate is not a good sample because when it's heated, it doesn't melt. It doesn't produce any endothermic melting points. So it cannot be reused. So in conclusion, the important thing to know that lignin and polybutylene succinate comes from plants. When they are mixed, we can obtain an homogeneous component or a uniform component, and that uniform component can be processed or can be used to manufacture many articles like car articles, aircraft articles, medical devices, pharmaceuticals products, dishes, plastic bottles, plastic cups. But you need specific instrument to treat or to manufacture those different articles. And the main instruments are extrusion machine and injection molding machine. So in the next part of my video, I will show you how I manufacture plastic bag of different types. Plastic bag for consumer, plastic bag for covering devices like computers, many different things, many different articles. So thank you very much for watching this video. Bye.